Alrighty, let's see. More kind of wizard, I don't know, Dungeons and Dragons type stuff here. In a mystic dungeon, n magicians are standing in a line. Each magician has an attribute that gives you energy. Some magicians can give you negative energy, which means taking energy from you. Okay, you've been cursed in such a way that absorbing energy from Magician I, you'll be instantly transported to Magician I plus K. This process will be repeated until you reach the Magician where I plus K does not exist. What is K? In other words, you would choose a starting point and teleport with K jumps until you reach the end of the Magician's sequence, absorbing all energy during this journey. You're given array energy, and integer K return the maximum possible energy you can gain. Note that when you reach a magician, you must take energy from them. Whether it's negative or positive. K is 3. Absorbing energy from magician I, you instantly get transported to I plus K. So 3 is the gap between magicians. So if you can do 5 and 1, 2, 5 and negative 5, 2 and 1, negative 10 and 0, 2, negative 2 and negative 1, that adds up to negative 3, negative 3, or if you start negative 1. Okay. Okay. This seems on the border of easy, I want to say. This does not seem difficult. Not in the same way as yesterday's problem anyways. Okay, so K. K is 3. Huh. So the length of energy is 10 to the 5th. Length of energy is 10 to the 5th. Each energy is negative 1,000 to 1,000. Trying to think. Trying to think what would be the data structure for this. So 10 to the 5th, or what's like the general process here? The speed here is either binary search speed, which could be heap, or linear. Don't want to do quadratic. Three. So it's 5, negative 5. So if you think about doing it from backwards forwards, like you could start at this 1 and that's the only thing in the chain. Start with negative 5, that's the only thing, negative 10, that's the only thing, or start from the 2, which case you would include the 1. So it'd be like 1, and then add it with a 2. That's how you get the 3. I mean, I guess the basic thing that you could do might be just create the list of all possible values and then just find the maximum. Is there a better way of doing it? I mean, it's kind of linear, right? Yeah. Okay. I'm just going to create all, or create a list of all possible total values. Okay, so values is going to be, let's say possible array. So what's the logic here? N is the length of energy for every index starting backwards, maybe. I think I want a hmm, all possible, and then this is like the current possible set, depending on where you start. I want this to be 0 times the number of k, because it's going to go in a loop. And this is like for index in range, I guess this would be backwards, n minus 1, -1, -1. The current value is energy at this index, and then I want to do a loop in terms of like which possible bucket I'm in. Let's say bucket 0. I'll do current possible for this bucket is increased by the value. Bucket is equal to bucket plus 1 mod k. So I chain through the buckets. And then whatever the current possible for this bucket is into the possible. Sure. Current possible for this bucket. I guess I could also just keep track of the maximum energy. Turn max if all possible. I think this is right. Okay. Okay. Yes, I don't need this. I'm just getting track. I just want to keep track of the maximum possible. So maybe I just keep variable -infinity. And I say if the current possible for this bucket is greater than the maximum possible equals current possible for this bucket. And then return the maximum possible. Guess this is no longer a list. You do need to keep track of all the possible things, I think. Huh. How do you do faster than this? What the heck? You go through, I mean, this is kind of slow. Do you need, I think you definitely need to keep track of this. Guess I could do an in-place thing. Guess I could do an in-place thing where I store the value. Yeah, okay. I guess I could possibly get rid of this if I did in-place, like summations. Okay. So in-place summation would be something like energy needs to extend by 0 times k, and then go through all the indices. Yeah, just go through all the indices. Maybe n is now the, yeah, and then, no, it should be like that. And I just do something like energy at this index is added with energy at index plus k. And then I just return the maximum of the energy values at that point. But then it has to be zeros at the end. So it can't be just zeros. Max of energy from 0 to n. Is that faster? Okay. Somewhat faster. Okay, actually, yeah, I don't need this extend. I just need to start off at like n minus 1 minus k, because you don't really add anything. N minus 1 minus k, or is it n minus k? N minus 1, k is 1, then you want to start minus 1 from that. Okay, yeah. Okay, yeah, that should be fine. I guess I don't even need the maximum possible. And at that point, maybe I don't even need the n length of energy. Okay, if this is not like, if this isn't it, then I'm gonna be very surprised. Okay, I mean, that's pretty good. I guess my only wonder is if I kept track of a variable, an answer variable. Do you need to keep this value for later on? So answer if energy at this index is greater than answer equals energy at this index, and then just return rather than max energy, just answer. Whoa, I did it wrong. Oh, okay, yeah. It should just be answers. It's probably like a singleton. No, what's going on here? Yeah, okay. It's not looking at the initial set of values. Okay, yeah, I guess this just, yeah, this is just not good enough. Yeah, that's as good as I'm gonna make it, I think. I don't know how to get faster than this. Yeah, whatever, it's like, what is it? Same speed here. Okay, anyways, summary. So what is the thing here? What is the thing here? And consider that the n values for energy are, okay, consider backwards traversal over energy array. The first k, or the last k values in array match the exact total energy achieved by starting at those indices. So if k is like 5 and you have 100 things in your energy array, the last 5 is going to give you the totals if you start with any of those indices. And then the previous k values to that. So like from n minus k, n minus, I guess, like 2k to n minus k indices. Would add the values, the corresponding value in the n minus k in the last k set to it to get the total energy. So example, let's say array size is 100, k is 5. If you have the array at 92, the total, or is starting at 92, the total would be array at 92 plus array at 97, or basically array at I plus array at I plus k. Same idea applies to every k set before that. So in backwards traversal, modify the array by adding array at I by changing array at I equals array at I plus array at I plus k. That would give the correct total starting at I. Keep doing that for all indices, then return the maximum in place, or maximum value of this modified array, i.e. the array transformed, array transformed into a total energy array where array I gives the total energy starting at index I in the original array. Okay, time complexity is obviously going to be O of n, since there is a single backwards traversal over all indices of the array and constant work done. You're just adding a of I plus your AI plus equals AI plus k. Space complexity, this is O of 1, since with in-place traversal or in-place modification, no additional space. For data structure was used.